Hi guys, today I'm going to be working through the exercise 3.2 examples from your Year 11 Jacplus textbook. So this is quadratic equations with rational roots. So quadratic equations or quadratics, it's introducing us to where we're going to be later sketching the parabolas. And of course equations will have an equal sign, and roots is another word for solutions. And solutions are x-intercepts when we're dealing with the graphs, and rational, so if we've got rational solutions, it means that our answers or our solutions, we're going to be able to express them as a ratio of whole numbers. So in other words, fractions, there we can express them as. So in other words, it's the easier solutions that we need to find. So look, let's get started on that. The first thing here they have is 5x squared minus 18x, and look, I'm going to minus 8 on both sides, and the reason I do that is because I need to be able to use the null factor law, and null factor law means you have to equate to 0. So null means 0, so it's not the 8 factor law, we can't leave it equaling 8, we must equate it to 0. So I've done that. Now I can go about factorising, and look, I use cross factorisation. I always use cross factorisation, and you might have a different method, but I would say that this method is the best and the easiest to see that you're going to do the right thing. There's places where you can check that you're going right, so I'd suggest you use this one. So look, for 5x squared, we need to say 5x times x will equal 5x squared, and that's pretty much all we can do here. So let's see over this side for negative 8. There's a lot of ways I could make negative 8. I could say negative 8 times 1 equals negative 8. And well, that's not really going to be very good, because 5x times 1 is 5x, and x times negative 8 is negative 8x. So that's going to be negative 3x, and that's not our middle term. So what we want to get to is negative 18x. So that won't do. So I'll cross these out. I'm going to leave the 5x times x because, as I said, there's really no other way unless you were going to go negative 5x times negative x, which I think would be a silly idea. I think when you're dealing with the negatives, do it on this side. So let's try 2 and negative 4, and let's see what that gives us. 5x times negative 4 is negative 20x, and x times 2 is positive 2x. And that equals negative 18x, and indeed that is our middle term, so that is correct. So look, you might have done trial and error and tried a few different ones. Eventually you'll get to it. You just have to keep going, and as you get better, you'll be able to see pretty much straight away what the solutions are there, and the cross multiplication just gives you a chance to double check that you've got the right value. So I've circled those horizontally, and the reason I've done that is because in my brackets now I need to write the things that go across from each other. So 5x plus 2. So it's not 5x minus 4. So notice I go crossways, and then x minus 4. And that equals 0. So I've factorised this, and I'm equating it to 0. And because of the null factor law, so let's move down a little bit, because of the null factor law, if either of these equals 0, so just pretend that this whole thing equals 0. It doesn't matter what the second one equals. The second one could equal 100. You're still going to get to 0. By the same token, we could say, well, let's say this bracket equals 0. If we're multiplying that by negative 2000, we're still going to get 0. The point is that it doesn't matter what you multiply 0 by, you still get 0. So it means that if either one of these equations equals 0, that will mean your equation is correct. So that means you've found a solution. So the first one, 5x plus 2, that can equal 0. So let's minus 2 on both sides, and we get 5x equals negative 2, and let's divide by 5. And there is our rational root being negative 2/5. So that's one solution. So if we were to sub negative 2/5 into this, we'll get 0. We sub negative 2/5 into this, we won't get 0, but because we're multiplying by 0, the whole thing will equal 0. let's do the next one. So this one's a bit easier. X minus 4 equals 0. So we're going to add 4 on both sides. So that's our second solution. So look, people can get confused here because this one, the answer is just the opposite. So it says -4 in the brackets. Our answer for X is +4. So don't be fooled though, because in the other bracket here, this is a +2. Our solution is not just -2. The reason it's -2 fits is because we have undone it. We have solved 5x plus 2 equals 0. So it's important that you keep that in mind. That's a common mistake. People will just write the opposite of the last term, and then they will be wrong in some cases. All right, so that's that part. Let's go to the next bit, and I just might put that over here so we've got a little bit more space. So the next part, B. Given that x equals 2 and x equals -2 are zeros of a quadratic, form its linear factors and expand the product of these factors. All right, so this is really quite easy. It's just the wording is a little confusing. So x equals 2, that means x minus 2 equals 0. So that would be one of our factors, because remember, if x minus 2 equals 0, we'd be adding 2 on both sides. That would mean x equals 2. So x minus 2 is the factor for that one, or is the what we're going to put in the brackets. For the next one, we've got x equals -2. So here. So if x equals -2, that means x plus 2 equals 0. So we minus 2 on both sides. You see how you get x equals -2. So for this one, we can say this would be our brackets. So in other words, our expression here would be x minus 2 and x plus 2. And actually it's an equation, it equals 0. So now we can expand that. They want us to expand the product. All right, let's do it. So we can do this in two ways. The first way would be to identify the rule, and this would be a minus b, a plus b. And we know that a minus b, a plus b is a squared minus b squared. So that would be x squared minus 4. So we could say like this. But if you are a little unsure of your rules and you do want to really know them, so if you are a little bit unsure, you probably should do a little bit extra work on difference of perfect squares and the other identities. But in any case, you can expand with FOIL. X times x is x squared. X times 2 is 2x. -2 times x is -2x. And -2 times +2 is -4. So here you can see that actually we are going to say positive 2x minus 2x. That goes. So we're left with x squared minus 4. So that would be our expansion, x squared minus 4. And it doesn't matter which way you do it, but it is good if you can see the identity, if you can identify that's a squared minus b squared there. All right, let's move on. Okay, so the next one, solving this equation. So this one's quite, I like these, and I think people, once you get the hang of the identities, you can see very clearly how to do these straight away. So when I talk about the identities, I'm talking about a squared minus b squared. So difference of perfect squares being a minus b, a plus b. Others that we want to know is a squared minus 2ab plus b squared. So that would be a minus b squared. And then we have a squared plus 2ab plus b squared. And that's a plus b squared. So if you're not sure of those, that's year 10 or even year 9, there's quite a lot on those. You might like to have a look back. In any case, we can do this worked example 2 in one of two ways. So the first way, and probably the better way I'd say, not because it's more correct answer, but just because I think it saves you time, is you can see that we have a squared minus b squared. So use the difference of perfect squares. So a squared minus b squared equals a minus b, a plus b. And, well, if we identify a squared, it's 2x plus 3 squared. If we identify b squared, it's 25. Notice that this negative is not part of the 25. The negative is part of the identity. It's already there. We're just identifying a squared and b squared at this stage. So then a must equal 2x plus 3, and b must equal the square root of 25, so 5. So now we can just pop them into a minus b, a plus b. So a, 2x plus 3, minus b, which is 5, and then a plus b. And let's make it look a little nicer. 2x minus 2 and 2x plus 8. And if we were just, if it was an expression, so if we didn't have equals 0, if we weren't solving, you'd want to remove the 2 from each of those. But you don't need to if we're solving, because when we solve, we're going to be accounting for those 2's anyway. So let's null factor law. This can equal 0. And this can equal 0. So let's deal with this one. 2x minus 2 can equal 0. So add 2 on both sides. 2x equals 2. Divide by 2. X equals 1. And the second one, let's put it here. So 2x plus 8 can equal 0. So let's minus 8 on both sides. 2x equals negative 8. And let's divide by 2. X equals negative 4. So our two solutions are 1 and negative 4. And that's if we use the identity a squared minus b squared. I'm going to do this question a second time because you don't need to use that identity if you don't want to. You can do it in a different way. So 2x plus 3 squared minus 25 equals 0. Let's double check. 2x plus 3 squared minus 25 equals 0. Yes. So look, let's now just solve it by undoing the equation. So I could, instead of, if I didn't see that that's a squared minus b squared, I could say let's add 25 on both sides. And I'd get 2x plus 3 squared equals 25. Then I would square root both sides. And the little bit tricky thing with this is that you've got to remember the plus or minus. So if you write just 5, if you just only write 5 there, you're only going to get one of your solutions. So you won't get all your marks. Here I've got plus or minus 5. So that means 2x plus 3 can equal 5, or 2x plus 3 can equal negative 5. So it's just a fancy way of writing these two things. Let's minus 3 on both sides. So x equals 1, and that we already found before. We saw that x equals 1, so you see we get the same answer there. Here it is. The next thing we're going to hopefully see is negative 4. So let's minus 3 on both sides. 2x equals negative 8. X equals neg 4. So just as we expected, it's 1 and negative 4. So either way that you want to solve that is fine. I think it's probably better if you are good with the difference of perfect squares. So where possible, if you can identify difference of perfect squares, try and use that. Let's go to the final example, I think. Yes, the final example. And here we have something a little bit more tricky looking. It's got coefficients in front of all of the x to the power of 4, the x to the power of 2, and then we've got a 9. I like to see if I can take something out. And if I could divide by 2 or 4 or 3 or whatever, if I had a common factor there, I would. Unfortunately, I do not have a common factor, so I'm not going to take anything out. But I will note that I've got x to the power of 4 as my highest x indice there. So I'm going to say let z equal x squared. So if z equals x squared, that means 4z squared, because x to the power of 4 is the same as x squared squared. 2 times 2 would be 4. So by writing it like this, I'm going to get rid of the power of 4. And it means that I can solve this with my cross factorization as per usual. So I've substituted z for x squared, and now I can say, well, let's say 4z times z. And I mean, it could be, actually, let's do one that I know is going to be wrong first so I can show you the trial and error process. So 2z times 2z equals 4z squared. 9, let's do 3 times negative 3. So let's cross multiply. 2z times negative 3 is negative 6z. 2z times positive 3 is positive 6z. And that equals 0. So that's certainly not what we want. We're trying to get to negative 35z. So let's see what we can do. And as I said, as you get more used to these, you will easily identify the pairs. So I'm going to go 4z times z. I need quite a large number, so negative 35, well, quite small, but I think I'm going to put negative 9 here, because then I've got negative 36 here, and then, yes, positive 1 here. So negative 9 times 1 is negative 9. Let's cross multiply. 4z times negative 9 is negative 36z. Z times positive 1 is plus 1z. So that's going to be negative 35z. And that is what we want. It is our middle term. So now that I've got the middle term, I know that my brackets are going to have those going that way. So let's do that. I'd just like to change the colour, but oh yeah, there we go, it'll let me. So now I've got 4z, no, it doesn't want me to change the colour, so I'm just going to leave it as yellow. Hopefully you can see that well enough. 4z plus 1 and z minus 9 equals 0. And let's try and change that colour again. Yes, all right, so now I can use the null factor law. This can equal 0. And z minus 9 can equal 0. So let's solve. I'm going to minus 1 on both sides. Kind of running out of room a little bit. Okay, so we've got 4z equals neg 1, and that means z equals neg 1/4. And then I've got plus 9 on both sides. That means z equals 9. Now, a lot of people will leave it like this, but this is not the answer. Remember, we're looking at x. So remember, we're solving for x. We're not solving for z. Z was just the pronumeral we used in order to make it a little bit easier to work with. So now I can say, well, let's say x squared, because x squared is z. If z equals neg 1/4, x squared equals neg 1/4. And now I have to square root both sides. And you can't root a negative. Can't root a negative. It's always positive. So this we reject. Therefore, reject x squared equals neg 1/4. So we don't use that answer. However, 9, if z equals 9, then we can say, well, x squared equals 9, and then x will equal plus or minus 3. And that is a solution we can have. So our answers for that is x equals positive or negative 3. And that is the end of the examples.